What up, what up? Welcome to part 5 and the last part of Let's Get Ready for AP Precalculus. Now, I'm going to be honest, full disclosure, I am a high school math teacher. This is the first year that anybody is taking AP Precalculus, the year 2023. But 2 years ago, I taught geometry, and many of those same exact kids are coming back to me for AP Precalc. But also 2 years ago, we were just getting out of COVID. We had to shut down for a week. We had to have some virtual days. We had to, do certain things to get back into the flow of things. So I, as a geometry teacher, did not get to get to trigonometry, which is what we're about to do. Now, if you've never seen this before, and this might be the first time you're seeing it, please keep watching. If you've seen this before, bring it all back. Trigonometry is all over precalculus. Precalculus is dominated by trigonometry. So whether this is the first or 15th time you've seen trigonometry, follow along. It'll be good for you. Now, what I have here first is a right triangle. Now, in the last video that I have, we did a lot of Pythagorean theorem and 45, 45, 90 triangles and 30, 60, 90 triangles to find missing sides and stuff like that. What this does, trigonometry, is this replaces those if I don't have pleasant angles. Like if I don't have a 30, what if I have an angle of 43.2 and you don't have any shortcuts for that? Well, over here on the left, you see SOH CAH TOA. SOH CAH TOA takes care of all that. Now, before we look at SOH CAH TOA, we need to look at this right triangle first. Okay, this little angle is denoted by the Greek letter theta. Okay, my angle, that's not a zero. My angle measurement is going to be given to me by the Greek letter theta. And I have to compare these sides to the angle theta. So when I look at theta, what is that long side right there? Well, it's always the hypotenuse. Don't lose any sleep over it. Hypotenuse, bada bing. When I look at theta, what is that side over there? That side is the opposite side to theta. And when I look at theta, what is this side right here? That's the adjacent side. Now, if you're thinking, isn't hypotenuse also adjacent? Yes, it is, but the hypotenuse is always the hypotenuse no matter what. Now, SOH CAH TOA is an acronym, and my 3 trig functions are sine, cosine, and tangent. So this obviously means sine something. What does it mean? Well, sine stands for sine theta equals the opposite side, and I'll just abbreviate it, over the hypotenuse. Okay, so if for some reason I told you I need to find that angle, and I've given you the opposite side and the hypotenuse, you are going to use sine. Ca, which is what I call my friends, stands for the adjacent side over the hypotenuse. So we will say cosine theta equals the adjacent side over the hypotenuse. Last but not least is the tangent. And the tangent, OA, you probably guessed it, is going to equal the opposite side over the adjacent side. Okay, now these 3 trig functions, sine, cosine, and tangent, I know you're like, isn't that sin? No, we don't listen to sin. We don't believe in it. This is sine, and that is not cos, all right, like the Cosby. No, that's cosine, and that's not tan, like what I'm getting during this summer. That's tangent. Okay, these are all abbreviated for trig functions. And unlike the last chapter where I called you all Simpson noobs for using calculators, we are going to need calculators. Now, I'm going to be using Desmos, and you have to make sure that you click on the little, the wrench here and set it to degrees. So if you see me go off to the side, it's because I'm using my calculator. If you're using a TI or a Casio or some kind of graphing calculator, make sure you have that set to degrees, and usually you click mode and you set it from degrees. The other option is radians. Don't choose radians. In pre-calculus, we will deal with radians, but in geometry, we're not. Okay, so find the trigonometric ratio. So we're starting out simple. We're starting out friendly. Okay, it's asking me to find the tangent of x, not even find it. It's asking me to find the trigonometric ratio. So I'm thinking, oh, tangent, SOH CAH TOA. So what I need to find, the tangent of x is going to be TOA, the opposite side over the adjacent side. Let's go to our right triangle. X is this guy right here. I need to find the sides based off of my angle right here, and I'll even put the angle X in there so you can see it a little bit better. I care about the opposite side that is opposite to X. That would be 32. So 32 is my op. Also, which one's my adjacent, 40 or 24? Well, 40 is the hypotenuse, and the hypotenuse is always the hypotenuse, so it's not you. It's going to be you. Okay, so tangent of x is going to equal my opposite side, which is 32, over my adjacent side, which is 24. And depending how picky you want to be, I can go one step further. And I'm going to keep it as a ratio. I'm going to keep it as a fraction because it says ratio in the directions that I created. If you divide both of those by 8, you get 4/3. So that's what tan x is. Okay. Right now, all I'm doing is finding the trigonometric ratio. I'm not solving for x. We will deal with that soon enough in this video. Find the trigonometric ratio again. Okay, let's make one up. I didn't have anything. Let's do sine A. Okay, sine A. So sine, sohcahtoa, so SOH, sohcahtoa. The so part stands for the sine of my A is going to equal the opposite over the hypotenuse. The opposite over the hypotenuse. So let's find A. Again, this is all in relation to what angle I'm dealing with, and we're dealing with A. So I need to find the side opposite of A, and it's 32. So we'll do opposite right there. I also need to find the hypotenuse, and the hypotenuse is always the hypotenuse, 40. Okay, so sine A, no, I can't use that color. Sine A is going to be my opposite side, which is 32, over the hypotenuse, which is 40. Again, the same exact numbers it seems like we had last time. They're both divisible by 8, so not the same exact numbers, but very 80 numbers. Divide both of them by 8, you get 4/5. So that's the trigonometric ratio. Okay? So I didn't find anything. I didn't solve for any angles or anything like that. Usually when I give you a problem like that, if I'm asking you to find the sine of something, the whole goal is to find out what the measurement of that angle is. Not yet. Soon enough. Be patient. Now, this is how we would do it. Let's say that I want to find the angle measure. Let's say that I give you a right triangle and I say, find the measure of W, and you do a similar process to what we just did, where you have a letter over a letter, or a number over a number, and you get that, and now you need to get W all by itself. If you want to get an angle all by itself, what you need to do is something called the inverse trigonometric function. In this case, the inverse cosine. And what that looks like is this. That's supposed to be an S, cosine with a little inverse thing to it. Some teachers use this. It's called the arc cosine. There's also an arc sine, an arc tangent. There's the same thing here. There's also an inverse sine and an inverse tangent. We're going to use that always, so I'm going to get rid of it right now to get rid of all the confusion. Now, how do I get rid of W? The opposite of cosine is inverse cosine, and you do that to both sides. Inverse cosine, both sides. Okay, put that in parentheses because it's proper. Put that in parentheses because it's proper. It's very similar to like dividing both sides, but we would never say divide both sides by cosine. That's a completely different animal that you are going to see a lot in pre-calculus. Cross you out, W is all alone, hooray. Now, what the heck is the inverse cosine of 0.6157? I don't know. So what we do is we run to our calculator, and whether you're using a Desmos or whether you're using a TI-80, whatever, which I do have. Do I have batteries in it, though? Ugh. Oh, no, it's a TI-89, titanium. Batteries are dead. So you would look at this, and maybe you can see it, maybe you can't. The inverse cosine is there in green. So you would hit like this little green button and you would hit the inverse cosine button. If you have a TI-84 or a TI-80 something, which I should have, but I don't remember where I put it, you would use that to, can't find it. So what I'm going to do is I'm going to go to my Desmos and I'm actually going to type in inverse cosine, or I'm just going to hit the functions button and find inverse cosine, which is pretty much right away, and type out 0.6157. Okay, I don't know how well you can see that. There you go. And I'm just going to hit enter, and it's going to definitely not be a pleasant number. It's not, but it looks like it's roundable. So 51.997, which I'm just going to round up to 52 degrees. Remember, whenever we take the inverse sign to solve, we are finding an angle measurement. That's the goal. That's the point. If for some reason you didn't get 51.997, it's because your calculator is set to radians. Set it to degrees. Okay? Done. Now, this is where inverse of trig functions, all the stuff that we did so far, become very, very, very important. My goal is to find the missing angle here. Let's call it theta. Okay? We're going to do this. Probably the most important part about pre-calculus is what we're about to do. So make sure if you're watching this and seeing it for the first time, rewind it, watch it again, watch it again, watch it again. My goal is to find theta. Okay? Theta is important to me. So I'm thinking sohcahtoa thoughts. And what I need to do is I need to figure out how and is 9 and 21, 9 plus 9, how is that related to theta? Okay, if I look at theta, what is 9 to me? Well, 9 is the opposite side. If I look at 21, 9 plus 10, what is 21 to me? 21 is the adjacent side. Okay, so I need to figure out which trig function I'm going to use based off of the fact that I'm given the opposite side and the adjacent side. So I need the one with the OA, and there you is. So I need tangent. So let's set it up. Tangent of theta is going to equal, leave myself some space, the opposite over the adjacent, 9 over 21. If you're wondering, why did he whisper kind of to himself, leave some space? Because I need to find theta. I don't have theta. I have tan theta. Tan's in the way. How do I get rid of a tan if the tan is blocking theta from being alone? The inverse trig function, and I'm going to do that to both sides. So I'm going to inverse tan both sides. Look at me leaving some space. That crosses u out, and theta is now by itself. What I do is I run to my calculator or to my Desmos, and I type in the inverse tangent of 9 divided by 21, and it gives me 23.19859. So I'll do 23.199. Okay, 23.199. Now this is theta. I didn't use theta originally, so to make sure that I'm a purist, I'm just going to say the missing angle is 23.199 degrees. So that's what trigonometry is used for. Trigonometry is used to find missing sides or angles, and in this case, an angle, if I'm not given a ton of information. And that's what I got. It's a missing angle. Find the measure of the missing angle again. So the same exact rules apply. I'm thinking SOH CAH TOA. I'm looking at that question mark. I'm going to call you theta. Theta compared to 42 is my hypotenuse. My hypotenuse is always the hypotenuse. What's 40? 40 is the opposite. So I need to come up with a trig function that uses the opposite and the hypotenuse. So does that just fine. So I'm going to set up my equation. Sine of theta is going to equal the opposite, which is 40. Should have left myself more space. Over 42. Is theta all by itself? No. Sine is in the way. How do I get rid of sine? Inverse sine both sides. Inverse sine both sides. That crosses out. And now you are left to find the inverse sine of 40 over 42, which I'm going to do right now. Again, you're going to definitely need a calculator for this. Make sure it's set to degrees. 40 over 42. And I get 72.2472. So I'll write all that out. 72. What did I say? 2472. Which means the missing angle is 72.2472 degrees. Okay, so again, I look at this guy right here. I need to find the missing angle. If I need to find the missing angle of a right triangle, or I'm not given the other triangle, but I'm given two sides, we're going to use trigonometry. And so I compare my sides to theta. And my sides are hypotenuse and opposite. So that requires sine, because sine deals with the opposite and the hypotenuse. So I write out sine theta equals 40 over 42. I need to find theta. So you inverse sine both sides, type it in your calculator. Bada bing. Bada bing. Ooh, now it's a little different. Now I have to find the missing side. I'm given an angle. I'm given one side. It's not a special case right triangle. I can't use Pythagorean theorem. So I look at this and I have to use trigonometry. So the angle that I care about is the only one that's given to me, other than 90, 15 degrees. So let's compare x and 16 for 15 degrees. X is the hypotenuse no matter what. 16, okay, in reference to 15 degrees is the opposite side. So once again, I need the SOH CAH TOA that involves the opposite and the hypotenuse, and it's so again. Okay, oh man, we have fun. So let's set up our equation. Sine, not theta this time, because I know the angle measurement. Sine 15 is going to equal the opposite, which is 16, over the hypotenuse, which is x. Okay. Now, I don't need the inverse sine. I could just type out sine of 15 right into a calculator right now. So I'm going to do that. Sine 15, and it says 0.2588. So sine 15 is 0.2588. That's going to equal 16 over x. Now, my job is to solve for x. X is in the denominator of a fraction. So I have a number equaling a fraction. Why don't I make this a fraction and do proportions crisscross applesauce? Is this necessary? Nah, but this is just the way I like to do it. So whenever you have a proportion, you crisscross applesauce, you multiply those guys together. So that's 0.2588 times x is going to equal 16 times 1, which is 16. Is x all by itself? No. Divide both sides by 0.2588. Divide both sides by 0.2588. cross you out, and then I'll get x. So 16 divided by 0.2588 is going to be 61.819. No units of measure to worry about, nothing like that. Blackpink once said, how you like that? But now I'm saying nothing like that. Oh, man, the last slide of this whole thing. Oh, I feel like we've been together for years, but it's only been like 2 hours. Find the missing side. Same type of problem. I'm given an angle. Here's my angle. I'm giving a side, and I need to find the missing side. I need to see what 21, 9 plus 10, and x are compared to 68. 21 compared to 68 is going to be my adjacent side. X compared to 68 degrees is going to be my opposite side. So I need the SOHCAH TOA that deals with the adjacent and the opposite, and that is TOA. So I'm going to use tangent. Let's set it up. Very similar to the last one. I'm not using theta. I'm given the angle measure. So tangent of my angle measure is tangent of 68 degrees is going to equal the opposite, which is x, over the adjacent, which is 21, 9 plus 10. Okay, you run to your calculator and you type out tangent of 68 degrees. So tangent 68, and it's going to be a terrible number, 2.475. So you become 2.475 equals x over 21. Now, I'm not going to turn this into an over 1 because all I have to do in this case is multiply both sides by 21, and that's going to make life a lot easier. So you don't need a proportion. You could, but you don't need it. That gets x all by itself. And now I need to do 21 times that number. And 21 times that number is 51.9768. So let me write that out over here nice and big. X equals 51.9768. So the last 5 videos, we dealt with a lot of solving equations. We dealt with a lot of factoring and graphing quadratics. Okay, we dealt with some geometry. We dealt with some trigonometry, some Pythagorean theorem. All of this stuff is not designed to help you master pre-calculus or AP Precalculus, but so that you walk into your AP Precalculus test or class, which is going to kick your butt. It's hard. And you feel a little bit more confident, you feel a little bit more comfortable, so that when the teacher whips out tangent and you had a geometry teacher like me who, due to a pandemic, wasn't able to get to trigonometry, you kind of know what you're doing. Okay? So thank you. If you watched all 5 of my videos, thank you for doing that. If you haven't, you should go back and check them out. Don't forget to hit that subscribe button. Being a math teacher is very illustrious, and I make a ton of money, but I could always use more. So thank you guys so much. Love you all. Good luck on AP Precalculus. You'll do fine. I believe in you, stranger. Bye.